Recently, the fast breeder reactor situated at a kalpakkam has achieved its criticality. That is a major step in India's uh, nuclear program, which consists of basically three generations. Most of the our reactors right now is a pressurized heavy water reactor, which use uranium 235 and uranium 238. When the nucleus of uranium 235 or 238 is bombarded by the slow moving neutron, then the nucleus of U235 get split, and not only just energy, lot of energy is produced, but at the same time neutrons as well as plutonium is also produced. These neutron again bombard the another nuclei, and that's how the chain reaction goes on. So our first generation reactors are basically pressurized heavy water reactor. The problem with these uh, reactors is that they are highly inefficient because they use only 1% of the uranium 235 to produce the electricity. The rest of the uranium 235 is left as a depleted uranium. That's why in the second generation, which involved these fast breeder reactors situated at a kalpakkam, we are going to use the plutonium. We are using the plutonium with the depleted uranium, which is also a byproduct of the first generation pressurized heavy water reactors. So in the first generation, as we have just seen, that not only just energy but the plutonium is also produced, and at the same time lot of uranium 235 is left as a depleted uranium. So in the fast breeder reactor, we are using the plutonium as a fuel, but the core of these fast breeder reactor is surrounded by the blanket, which is made up of depleted uranium produced in the pressurized heavy water reactors. So when this blanket is bombarded by the neutrons, then this depleted uranium get itself automuted into plutonium. That means in the second generation, in this fast breeder reactor, we are producing more amount of plutonium, which will be used in our third generation program with the thorium. So our scientists, especially the Homi Jahangir Bhabha, which is considered to be a founder of India's nuclear program, realized that the uranium is not available in India in a sufficient amount. That's why if we have to make India as a uh, you know energy secured nation, then we will have to use thorium, which is found uh, in the form of monazite sand in Kerala. So that's how the three generation program was envisaged. But the problem with this fast breeder reactor is that although they are more energy efficient, they are more efficient because they at least they use 10% of the nuclear fuel to produce the energy. But the problem with this fast breeder reactor is that they use liquid sodium as a moderator, and that's why all the pumps and pipes in the nuclear reactor has to be made leak free. That is the problem associated with these fast breeder reactors. That's why many countries like France or Japan has uh, closed this fast breeder reactor in their country. but it is important from the perspective of our third generation program. And because this fast breeder reactor has achieved its criticality, so criticality here means that it does not mean that this fast breeder reactor can be put for commercial uses or we can produce electricity with the help of this fast breeder reactor. Criticality means that this reactor is now in a stable situation. For example, in this reactor, the self-sustained chain reaction is going on. The temperature and other parameters are within the limits. So it is some kind of stable condition. But this reactor will have to be observed for many months before it can be used for producing the electricity. But it's a great milestone in India's nuclear program.